Hello, and welcome to this week's live stream. We'll be talking about NVIDIA robotics. And as you may have noticed, Edmar is not here. And it does make us very sad that Edmar is not here, but it's for a good cause. He is at SIGGRAPH right now. And if you're at SIGGRAPH, one, I hope you get to meet him. And two, today is OpenUSD Day. So I hope you get to go. Today we'll be talking about, well, I'll be doing a few announcements, and then we're going to spend most of our time answering your questions and talking about the brand new, super shiny Isaac Lab 2.2 release. And next week, we'll talk about the also brand new and also shiny Isaac Sim 5.0. So today, Isaac Lab 2.2. Next week, Isaac Sim 5.0. So if you want to learn all about these new releases, stick with us today and join us next week. And of course, you know him by now, but we've got Asa with us today, and we've got Oyinda. And for those who are new for the live stream, my name's Eric Bowman, aka Strainflow, and I'm a technical marketing engineer. I mostly focus on virtual factory integration in robotics, and my goal is to help as many people as I can use NVIDIA technologies to solve their problems in that space. And then Asa, would you introduce yourself, and then Oyinda?
Yeah. So, hey everyone, my name is Asaviri, and I work with Eric and Oyenda on the tech marketing engineering team. So, we work on a lot of cool robotics platforms and features and tools, and these office hours are just a way for us to share all of those things and answer your questions if you're also using these platforms. So, just super excited to be on this live stream, and hopefully today we can share some exciting new updates in Isaac Lab.
Cool. Okay, thanks, Asari. Thanks, Eric. Hi, everyone. My name is Oyin Damala. I'm also a technical marketing manager for robotics. So basically what as I said, we work on different kind of platform, Isaac Sim, Isaac Lab, Groot, different kind of robotics workflows, research blogs and things like that, just so that the developers can, you and also our teams can also use most of this software in a way that it's understandable, in a way that it's clear, and then to be able to answer most of the questions that you have. Thanks for having me here today.
I'm so glad to be with you two today. And if you're new to this live stream or not, please post questions. And if you're a little nervous to ask that first question, just let us know where you're watching from. We're curious where you're all from, and we're curious to know kind of what your interests are or what brought you here today. So we love to hear from you. And this is an office hour, so we really hope to have some great questions from you that we can answer and help you with. That said, there's a lot going on right now because it's SIGGRAPH week. And so I want to start by just sharing a kind of a few of the biggest things going on. So, and you can just put your camera on any of these QR codes and they'll take you to some very nice blog posts where you can learn more about this stuff. And of course, what we're talking about today and next week is the new release of Isaac Sim 5.0 and Isaac Lab 2.2. And check that out. And then something they were talking, well, and then I believe they talked about this at SIGGRAPH, but Amazon is using NVIDIA Omniverse to create digital twins of their factories to help simulate their processes and get towards kind of what's called a zero-touch manufacturing, which is manufacturing where humans aren't even part of the process. It's really cool stuff. And then this article is all about just robotics, and really there are a lot of new technologies coming out from NVIDIA to help robotics and robotics simulation. And this blog post is a really nice overview of those technologies to help you get up to speed if you're curious what we're improving there. And so if you missed the special presentation by the NVIDIA research VPs that happened on, it was Monday afternoon. I hope you'll check it out. It's fascinating. And one of the things that they talked about was the NVIDIA NeuRec, which is neural reconstruction of scenes. And this blog post actually has a little step-by-step tutorial that shows you how to create a neural reconstruction yourself. It's a fascinating blog post, and of course, I always love hearing from the NVIDIA researchers. So I hope you'll check out that presentation, and I hope you'll check out this blog post. And then, and then also the researchers talked a lot about Cosmos, and you've probably heard us talking about it too. But there are a few different Cosmos AI models that you can use um, to recreate and work with the real world, and so check the article out if you wanna learn more about that. And then finally, we have all these cool resources for you. Check it out. We've got our ad event calendar, we've got forums, we've got Discord, and we've got wonderful ambassadors. So check out these QR codes and learn more about what we're up to. And I think with that, I'll turn the time over to Oyinda and bring up her screen.
Awesome. Thank you, Eric. Thank you for all those tech blocks that you mentioned. So today we'll be basically talking about NVIDIA Isaac Lab 2.2 release. Definitely we have Isaac Sim 5.0 and Isaac Lab 2.2, and Isaac Lab is built on top of Isaac Sim. So next week we're going to have a live stream for Isaac Sim, and then we'll go through all of the cool features that we have for Isaac Sim 5.0. But for today, we'll focus on Isaac Lab. These are some of the features that many people have requested at previous live streams, and we're excited to come and show you where to get information about them, documentation, and also how to get started with them. So the first resource that will be nice for everybody to have is this announcement blog, where we have a list of what we released, what's new in Isaac Sim. You can easily read through it and then see what interests you, and play work with it, and then we will be glad to have feedback on both the GitHub forums. So I will just go straight to the release for Isaac Lab 2.2, and then we can walk through at least about 6 of the features. There are many of it, but about 6 of the features, and then see how it interests you, and then different ways you can adopt them. Of course, we have different ecosystem currently adopting many of these things, and it will be good to also check out what they are doing and how it relates to what you are also currently doing. So overview, there are 2 parts majorly that I'll be talking about, which is the enhanced physics support and also the teleoperation imitation learning side of work, plus GRUT N1 fine tuning. So one of the things that we added is enhanced physics support, which updates the joint friction modeling using the latest physics API. So this adds support for special tendons. So special tendons, basically tendons define the interaction between 2 joints, 2 articulation joints. So special tendons helps to be able to model things like hydraulics, actuators, and then which are very, very necessary when it comes to a special kind of articulation that is not like the regular, maybe the regular cylindrical, or maybe the regular robotic um, interaction of the articulation. So of course, it comes with also improved surface gripper interaction, because we do a lot of manufacturing tasks. So there's a lot of gripping that has to, occur. So those being able to simulate that accurately is important for sim to actions, and then we have those improved gripper action. This has like some reference links, so by the time you click on many of these links, you have more details about that. For instance, this is the one for the special tendons. Like I said, they define the constraints between 2 different links, and then modeling like hydraulic actuators, and elastic like mechanical components. And these are very important for some kind of applications that was not there before. So so that's exciting, and to be nice, if we can also try it out. All right,
Yeah,
so
can
yeah.
I just say how excited I am? I know it's a silly thing. I'm just so excited about. So the joint friction modeling now matches the Mujoko joint friction modeling. So there are a lot of people who are like, "Hey, How do you like go between Mujoko joint definitions and Omniverse joint definitions? Well, they've added that same friction parameter, and I'm surprised it doesn't mention it here. But it also they added torque speed envelopes and a lot better, just a lot better actuator modeling. And maybe they talk about it more on the Isaac Sim side because really it's kind of like an Isaac Sim improvement that you can use it from Isaac Lab. But I'm
Okay.
I'm really excited about that one.
That's awesome. That's awesome. So somebody asked a question: is there any visual tactile sensor that can be simulated in Isaac, the new Isaac Labs, Isaac Sim? Any links would be great. I would say okay, definitely we have some Contactrich environment. I won't talk about that, so I would wait for Asari to talk about that, and then we can see how to be able to simulate those kind of sensors. No. Okay. The other one is imitation learning. Of course, a lot of us have used like say SO101, to do different kind of data collection and then use that data to be able to train either a BCRN policy or maybe a Group N1 policy. So we included new environment into the imitation learning workflow, which introduced two new GR1 mimic environment with domain randomization, visual robustness evaluation, and some improved pick and place stacks. So previously we have, so this is the if you go to the Isaac Lab documentation, we have a specific section under overview that is for teleoperation and imitation learning. And Isaac Lab, under teleoperation, we've gone through this before in previous live stream. The devices that are supported, we have the keyboard, we have the space mouse, we have the AVP, and then we've seen like different people integrate, different kind of devices, like maybe gloves or different kind of XR devices that people can use with this. Even the SO 101 leader ham can also be used for teleoperation, and we've seen different kind of teams, like Lightwheel, using many of these teleoperation device. Of course, after data collection, the next thing you need is training. um After data collection, next thing you need is training. We have our platform first after collecting demonstration to scale up the demonstration. That's generating additional demonstration with Isaac Lab Mimic, which is under Growth Mimic. And then we had Frankenham environment before, and then we had like the GR1 environment, majorly for state-based policy. Now we have we also had the visual motor policy. The difference is that when you're um, you're predicting your action using state-based information like the end effector pose and things like that. But now for the visual model, you are predicting using like images, and then using images to be able to do prediction, which comes to visual arrow, visual data rather, that involve a lot of computation, but we have the tight camera which can help us to speed up computation, for us to be able to use visual motor policy. So we have different environment before. I think one of the environment we had was the GR1 with the steering wheel. That was already there before, but for the new release we had more long horizon pick and place stacks, which I will just quickly just go to where it is right here. Um, Sorry, 1 second. I know we have all of this information already. All right. So yes, we have a long range task. This involves number one, picking up a beaker and then putting a knot inside and inside a bowl, and then take that certain bowl and put it on a scale. This, of course, you must have seen in different blogs, but this is good for me to mention that this is open source for people to try out. And we have both two things. One is trained for using BCRNN. That's a basic policy that we have in Isaac Lab imitation learning platform. But of course, one of the big question people ask is that how do I integrate Isaac Groot, not as a open loop evaluation? So open loop evaluation means that you take some data, you train it, and then you you're not taking that trained policy back in simulation for you to be able to do like things like software in the loop or hardware in the loop. That's a closed loop evaluation. But open loop evaluation, you just have the policy and then you can deploy directly on your real robot or and then if there is something that fails, you have to still go back, retrain, and all of those things. But having software in the loop, in having simulation, helps you to be able to try different number of data sets, different number of demos, and to be able to evaluate that this your policy actually runs real time, and do a good closed loop evaluation for it, using like closed loop evaluation success rates to be able to define how well your policy is running. So this is something that I
So
know.
I'm
Yeah,
sorry, but I've heard people talk about open loop evaluation before. And can you explain that just one more time? I didn't
yeah.
quite get it.
Okay, so if you look at the Isaac Growth repo, one of the things that happen is that okay, maybe I can just quickly go to Isaac Growth repo. Um okay. Okay, I think this is where I was going to. Now you have to make me go faster. That's okay.
I'm sorry.
That's all right. That's all right. That's all right. Okay, it's fine. I'll just go to the repo. So we have the Isaac Growth repo right here. And then
So
one of the things you
and so for
see,
people who aren't familiar, while we've got software in the loop, and software in the loop is essentially just we're simulating the environment in Isaac Sim, right?
yes, yes,
Now hardware in the loop just means that we're simulating the environment with Isaac Sim or some simulator, but then any inference we need to do is happening on our actual hardware that's connected to our computer.
yes, like Jetson, Tor, and like your robotics hardware. That's hardware in the loop. Okay, so let me just go a little step back about the evaluation that you asked. So on the Isaac route, so one of the things you have is an example of the data sets that you collected, right? And then you train the model using the data set. So Isaac route is our foundation model for us to be able to do like visual language action prediction. So you take vision, images, and language, tell the robots to do something, and then you take the robot state, and then the robot to do what you want it to do. That's a very simple way of explaining what that is. But then offline evaluation, we provide like a script to evaluate the model on a data set. So you already have the data set, you have the ground truth state, you also have the ground truth action. So when you have your train policy evaluated on that data set, that's a bit of an open loop evaluation of the model. You don't have like a real-time way of getting the state, more like a real-time way of getting the state, while because you already have the state, you already have the ground truth, so you're just doing inferencing at different point. But in the case whereby you want to you want an initial state, you want to predict the action, and then when you have your action, you want a real-time simulator or a real-time robot to be able to give you the next state, not like a data set, to give you the next state, more like real time evaluation. Then you're talking about a closed loop evaluation that's happening, and then you can actually evaluate the success rate, what does it mean, square error looks like, and all of those things. You can do that all in simulation now. Of course, when you're doing it on the hardware, what happens is that if the model is not trained well, then your hardware breaks and all of that, then either you are left with going to go and get more data. And I'm sure you don't want to do that on a GR1 because it's quite some cost right there. You don't want to train a
Yeah.
policy that you don't want to you don't want to ensure that it actually works well. And also now we have so that's what I said. Now we have the closed loop evaluation for this, and the link right there, or the repo where it is called Isaac Lab Eval Tax currently, whereby we have two tags. We have both the not boring tags and also the pipe sorting tags. So here we trained the pre-trained GROOT N1 policy, and then we ran that GROOT N1 in simulation. So of course this requires different kind of thing. If the whole workflow starts with what I said earlier about generating demonstration, taking it to GROOT Mimic to scale up the data. That's one way of getting data collection. And then use that maybe 1,000 or 2,000 or X number of the data points that you got using GROOT Mimic, and which comes as a format of HDF file, because I see a question about, is there a release on HDF to lay robot data format for training GROOT N1? So we have the first thing we have is a converter that converts your data. I think right here, when you, we have some optional data set you could try with instead of maybe creating your data set yourself. And then we have a converter, yes, that converts from HDF file to Lerobot. So when you can convert from HDF file to Lerobot, then you can use that Lerobot's GROOT format, GROOT Lerobot compatible data set to be able to train GROOT N1. And that
So
is how the format work. Yes.
we've got some more. We've got a question. So this is all good. So Julius Caesar asks, closed loop provides feedback. And so it sounds like
Yes.
with open loop evaluation, you have a pre-collected data set, and then you evaluate against that pre-collected data set and
Yes.
just judge it based on how well it performs. But you're not actually recording from the environment as you go. You have
Yes.
pre-recorded data.
Yes.
And then closed loop would be you're actually using real sensors. You collect data, and in real time, you run that through your models, and to and then
Yes.
you get results from that you can
Yes.
judge how well it did.
Exactly. Exactly. Yeah,
Oh,
exactly. So that's
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 great.
like feedback that you actually get from the
For
simulation
real.
platform,
Well,
the real
I
one.
guess it could be simulation or real world. You could do closed
Yeah.
loop software in the loop or closed loop ground
And
truth.
exactly. So of course you can definitely do it in on the hardware, but of course, like I said, simulation first is good so that you don't break things.
Right.
And also it will be interesting to see how that goes. And but of course, for some tasks, definitely you can go ahead and maybe, I mean, if you're working on S101, you can break it as many times as possible. But it's fine. We already have proved samples of how you can run it directly on a real robot on the Isaac Root platform, and with the X number of data set that you collect. I think we have an example for post-training Groot N1.5 on
Cool.
S101, and it's like at least maybe like 50 demonstrations. You should be able to do a simple pick and place stacks and all.
And I just want if I just want to say, for those of you who are new to our live stream, the SO101 is this really cool manipulator arm that was released by Lay Robot. Lay Robot's part of Hugging Face. And the SO101, you can buy two arms for less than $500. And the reason you want two arms is because you actually use one of those arms as a remote control. It's called the leader. And whatever you do with that leader arm, the follower arm will do the same thing. And so you can, and then what we're talking about with Groot is you'll actually use this process called imitation learning, where you'll guide that leader arm and you'll perform some task via remote control or teleoperation, and you record every kind of time step. You'll record like the motor positions over time, so that those are called trajectories. And so you record these trajectories to perform the tasks. And if you were going to teach a robot from scratch, how many demonstrations do you think that would take, Oyinda, without Groot Mimic? If you were just going to do it from scratch, if you wanted to teach how,
Robot. Okay. How
how
many
many,
demonstration do you use? Okay.
yeah,
Well, it's tax specific. How complex the taxes is, how how many demonstration you have to use. For instance, this particular tax using just 100 demonstration is was an well no 100 data point, 1000
100,
data point, right? So not
1,000.
100, 1000 data point. So that 1000 data point was generated out of 10 human demonstration. So it is either you
Right.
have 1000 synthetically generated data set for you, or 1000 human demonstration. And trust me, teleoperation is hard.
Yeah,
Difficult
well, and
and time
if you
consuming.
were going to do it all from scratch, just yourself without these tools, you would need to do a few thousand demonstrations by your hand, which would
Yep,
take you like weeks or months of
exactly.
just grueling, terrible, like just like eh, really
Yeah.
hard work. And even
And
that
it
would
has to
only
be
teach it. What was that, Asa?
it has to be really precise too. Like you can't
Yeah,
if somebody else's hand gets in the way while you're recording one data point,
done.
you can't use that data point. So it has to be
Yeah.
like yeah, really focused on the
If your
task.
cameras get bumped,
Yeah, or
done,
if the lighting changes mid, yeah.
done.
Yeah, that's done. All right.
And so, and then if you want to teach it like general tasks, like it's going to have no concept of what things are except for exactly what you put on the table in front of it. So if you teach it
Exactly.
with pens, it will only know how to do pens. And
Yes.
that's why, first of all, Groot is so amazing. So the Groot foundation model, it knows what pens are, it knows what blocks are. It has all of, they've done like thousands and thousands of demonstrations. They've trained it on YouTube videos. They've done all this training. So it kind of has a general sense of the world. And so then with maybe 1 or 200 demonstrations, you could teach it to do like how that specific robot works, but it'll have all this general knowledge of like what different kinds of things are and what different kinds of tasks are. And
Yes.
then, which is still a pain, to be honest, to do a couple hundred demonstrations. So then we have Group Mimic, which is this really cool tool. It's getting better and better. And if you could do like as Oyinda said, you do 10 demonstrations, and then you use Group Mimic, and Group Mimic will like flip those and make them left and right and translate the things around and randomize locations. And through this magical process that I don't understand, to be honest, it can take those randomized environments and use your 10 demonstrations to figure out how to complete the task in these randomized environments. And so it takes your 10 demonstrations and turns them into thousands of demonstrations on top of the Scrut model. So you can teach robots to do complex tasks with only a few demonstrations. It's really amazing.
Yeah,
Pretty
that's really amazing. Thank you so much, Eric. Thank you, sir. All right. I will just go to the next one real quick, and it's interesting how the questions that are coming also aligns with the next thing that we want to say. So that shows that everybody is following us and all. Of course, another way of generating synthetic data is through Cosmos, right? That's one of our product that we have. So one thing is in the case of if you're doing visual based tasks, one of the things that you want to check is that can this model work in a different let's say lighting condition, or maybe a different space, or let's say like moving the robot from a factory to say like a warehouse or different kind of location and all of that. So one of the things that comes with Isaac Lab 2.2 is what we call augmented imitation learning. So what's augmented imitation learning? So what we did here is that we use Isaac Lab imitation learning capabilities with the visual augmentation capability of Cosmos models to generate demonstration at scale so that we can train all this visual motor policy that is robust against visual variations. So what that means is if we first generate data from we have 10 human demonstrations and then we scale up using Gris Mimic. That's our blueprint that you probably must have seen a whole lot of time. Is that we take that HDF file and convert it into MP4 MP4 data, that's videos. Now there
wow.
are two. Then when you have these videos, so these videos comes in different kind of modalities. You have RGB, we have segmentation, we have depth, we have normal marks, and then that is now used as an input to Cosmos to be able to generate different kind of videos based on variating, say the I can say, okay, can you do it at night time, can you do it in the daytime, can you generate this video using like maybe changing some even colors of the things in the environment. So this was done for the cube stacking task for the manipulator. So you can see that right here, I can change, say, the color of or the material, the color of the franca arm, to, and then maybe the color of the box can also be changed. The color of the table initially I believe was black, and then we can change to like blue, and then so all of those information on how to be able to try that are written right here, and then they are good for us to be able to use. So when you have those videos, then you convert them back to HDF file, and then that can now be used to be able to train are policies. So we have pre-generated data sets with this visually augmented data available on Hugging Face for you to try out now, which I believe one of the questions that was asked is, do we have some of the Cosmos data set? Yes, we have them on Hugging Face for you to be able to use. So we merge both data sets. So we have some data set from Mimic. We also have some data set from Cosmos, and then we did different kind of training and evaluation and try to see how well does a policy like a BCRNM policy, or let's say works well on different kind of lighting conditions. And this is one of the results that we have. Like if you're just going to train with just the 1000 demonstration and Mimic with no variation in change, then you can see that, of course, the more you increase the number of data sets, you have more better success rate. And of course, when you have Cosmos inside of it, but by the time you start varying the light intensity or the light color or the light, the background, the table background, then you start seeing a whole decrease in success rate. And then you can see the whole value of using Cosmos inside of it, whereby where before you have no success and then you still have like some improvement of that. Of course, this can be improved with different kind of maybe different kind of prompts, different kind of maybe environment. These are all basic policies. Instead of using BCRNL policy, can I use a group N1 policy to be able to train Cosmos generated data set? So it's interesting that we want to see what you can do with this kind of data set or this kind of workflow that we currently have for you today to be able to try many of this stuff. And also, I think I believe I've covered some of the question. Does this new additional workflow also support Cosmos Ready data set side with HDF? Exactly what this workflow is doing. One question that comes up is, would you recommend using Cosmos Replicator in Isaac Sim for Groot's blueprint pipeline? Generating metadata for Cosmos in Mimic seems easier, but doesn't use Replicator, right? All right. So I'll answer this question right now. But also next week we're going to talk about Isaac Sim 5.0 release, which comes with a Cosmos writer. So like you have your environment in Isaac Sim, and then you use Cosmos writer to be able to generate let's say RGB depth and all of this modalities that then can now be used by Cosmos Predict to be able to get more data sets. And also, yes, Cosmos writer is what we have in Isaac Lab, and it's not definitely Replicator. So we have Cosmos writer, we have Replicator. Replicator is also another way of getting synthetic data generated in Isaac Sim. But I would allow maybe next week for us to be able to have more information on that.
And
So I think
mind if I
Eric.
just say that you've got different Cosmos models, right? You've got Cosmos Predict, you've got Cosmos Transfer, and you have Cosmos Reason.
Yes.
You also have Replicator, and they're
Yes.
all different tools, and
Yes.
they do different things, and you would use them in different situations.
Yes.
And they're all complementary. Sometimes you might use them together to build a workflow even.
Yes.
And so I don't think it's really should we use Cosmos or Replicator. It's more like, where should I use Cosmos? Where should I use Replicator?
Exactly. I think Asa had like a live stream last week about the Cosmos models. So that would be a very good resource for us to look into. Because of time, I need to switch back to Asa right now. So
I've also added the SDG with Replicator and Cosmos tutorial in our chat, so you guys can go to that link. We will elaborate more on it next Wednesday, I believe, but it's just a good example showing how you use both, like Replicator in Isaac Sim to create data, and as a next step, how you use the Cosmos writer to augment it with like visual diversity and different features. So if anyone wants to try that tutorial before next week and then come back with questions, feel free to check it in our chat right now.
yes, Eric said, many of these tools are complementary. Like the augmented imitation learning pipeline I mentioned is a combination of Mimic and Cosmos for you to be able to generate your data set and all. One final thing I'll just mention is that teleoperation, especially using like AVP, that's the Cloud XR runtime, before it just have the hand tracking, and now we have both edge tracking and hand tracking, and you can tell how important that would be when you're trying to do some kind of teleoperation that involve the head moving from one place to another. For you to be able to maybe change the viewpoint of what you're actually looking at. And also this as so we have new I won't say I'll use improved teleoperation tools that have been enhanced with these configurable parameters in Isaac Sim 5.0 slash Isaac Lab 2.2. I've tried it myself and I've seen that it really helps to improve data collection, and we'll be glad if people can try it out. So so in summary, that we have new environment for imitation learning. We have new workflows that combine mimic and Groot mimic and Cosmos, and also we have from Groot mimic data sets to be able to fine tune Groot N1 using for closed loop evaluation. So I'll switch over to Asa to talk about the other exciting and interesting features that we have for Isaac Lab 2.2. Thank you.
Okay, that was awesome. Oyenda, thank you so much. I'm seeing a lot of questions in the chat. So while I share my screen, maybe we can start talking about some of them. And feel free to keep posting, you guys. These are great questions. Okay, so seems like everybody is at SIGGRAPH. Yeah.
Yes. Yes,
True,
it's
true.
interesting that we have a course on the Cosmos writer currently at SIGGRAPH right now. So it would be nice to also check out some of the courses that we have at SIGGRAPH, which answer many of these questions that we have. So okay,
Okay.
so yeah, okay, access screen is right up. Okay, there was a question right up, so I wanted to just put. I said there's some issues with Raycaster in 2.1, which I guess wasn't solved in 2.2. Any idea when this might get resolved? Okay, what I'll say is that if we can help maybe post this on maybe like GitHub so that we can have our engineers look into it, because there are specific issues. If there are some issues, then we have to know what specific issue it is, and then we can actually look at covering all of that. Yeah.
Oh, weird. Can you hear me?
Yes, I can hear you. For a second, I didn't hear anybody.
That was weird. We all got muted. I must have, maybe I hit something, huh? Okay. Oh, I still can't hear Asa. Can you hear Asa?
No, I
William?
can hear, sir.
Oh dear. Okay, well, let's keep going with some questions until we can hear her. Luckily, you all have lots of questions. So, oh, I don't know. Great
So,
question.
Okay, I think you can hear me now.
Oh,
Maybe.
yeah, we can hear you
yes.
now.
Sorry about that. Yes, so let's take that one question.
Oh, sure.
Yes, so this is
Oh,
the.
sorry.
Oh, good.
Sorry. Asa and I
This
are both trying to bring up questions, and
Yeah, I think we're good now. So yeah, with this release that you're seeing now, public, it's Isaac Sim 5.0, officially 2.2. These are the newest releases. And if you've already been using it, like the previous version, maybe it's time to upgrade now to the latest ones.
yeah.
Okay, I think Oyenda may have answered this. Does CloudXR support MetaQuest 3 devices as well? And I think I'm not sure about the first part of the question, but as for the second part, can I teleoperate on my custom humanoid? You can, but of course there will be some setup involved here. So you will have to have your custom humanoid as an asset in your digital simulation. So you'll have to have that robot imported into Isaac Sim, for example, if you're using Isaac Sim as your simulation platform. Once that's in place, you'll have to set up the XR client, of course, and then you could use something like the Apple Vision Pro because we support that, and we've tested with that as well. Through the Apple Vision Pro, you can basically you can kind of teleoperate into the point of view of your custom humanoid and collect data that way. I'm not sure about the MetaQuest device though.
Okay.
Well,
Yeah.
and I would even
Yeah, I
say
think I can.
I don't know that we should support it directly, but we have a ROS2 bridge. So anything you can do with ROS2, you can do with Omniverse, really.
Yeah. So yes, I think what first I've seen people use the MetaQuest vest in Isaac Lab to be able to teleoperate. That's one thing for
Mm.
sure that it can happen. Secondly is that the Cloud XR provide you with retargeters. So in the Cloud XR on the teleoperation data on the teleoperation documentation, there is a section for setting up Cloud XR for custom retargeters. So if you have, what I mean by retargeters is like if you have a different robot that is not the same thing as what it's in maybe the Frankenham or the GR1, or maybe you have your custom humanoid. So all you need to do is to ensure that the Cloud XR knows your joints, and how many number of joints you have, so that it can actually retarget that particular and tracking information to your own humanoid. And that documentation is there. So definitely, if you want to try different humanoid, definitely you can. And for other devices, I would also say we can check what the community is doing, and we are all one, place, and then we can see how to use other devices apart from the Apple Vision Pro, if that's what we have.
Cool. All right,
Awesome. Yeah.
Asa, let's hear more.
Let's go. Yeah, and then of course we have more questions, but we'll take them up in just 5 or 10 minutes. Okay, so key highlights of this release. Oyenda spoke about a couple of these, like the new environments, the enhanced physics support. She also talked about teleoperation improvements. Let's talk a little bit about this one, which says new contact-rich manipulation tasks. So, okay, what is a contact-rich manipulation task, first of all? So when you think of robotic arms or manipulators, they obviously can perform a whole range of functions, right? Some of the more easy ones, though, are simple pick and place, where the gripper or the robot arm has to move a certain way and find the pose of the object it's trying to grasp. And then really it just has to go grasp the object and go put it at another location. So yes, that task in itself is fairly complex. But then there are manipulation tasks which get even more, or rather which require even more accuracy and precision. Those are broadly called contact-rich manipulation tasks. So just to give you guys some examples of what that looks like, in a factory environment, if you have a robotic arm that maybe needs to put gears together, so like if you have a collection of 3 or 4 gears and they all need to be kind of meshed together, that is a more fine-grained task that requires way more accuracy than a simple pick and place task. Another example would be like a nut and bolt insertion or a screw insertion, where maybe the robotic arm needs to actually fix 2 different parts together by putting a screw through them, right? That, again, you can imagine it's a very high precision kind of task. So these kind of more fine-grained high precision tasks come under this category of contact-rich manipulation tasks. And a couple of important things are at play here. So first of all, there has to be a very accurate understanding of the physics of how friction works between these parts, how the parts are actually oriented together to fit in a certain way. And all of these, of course, as you can imagine, they need to be very, very accurate. So to do these kind of tasks, you want to ideally train a model or a policy that learns from a bunch of different videos or actual demonstrations of this task being done. And then you can fine tune those policies for your specific setup. So if you're using maybe a different type of nut and bolt setup or whatever, like you may have something specific, we try to provide a bunch of policies that you can then fine tune for your application. So these are just some integrations that are part of the new release. It's called Forge and Automate. So I have the websites open for these, and I'll also be sure to share the links in our chat right now. But for now, what you need to know is that Forge and Automate are these frameworks or policies that kind of help you perform or help your robotic arm perform these contact-rich tasks. So they are meant for more fine-grained contact interactions in simulation. Of course, you can run it in Isaac Sim, and eventually you can do like a sim to real as well, and then deploy it on the real robotic arm as well. But let's go real quick and take a quick glance at what Forge and Automate actually are. So this is the Forge website. It stands basically for Force Guided Exploration for Contact-Rich Manipulation. And it's a very interesting work. You can kind of visit this website and see all the different videos of it actually working in simulation or working in action. What's important to know here is that it's this framework for sim to real transfer of manipulation policies. So I believe it's a few shot or a 0 shot kind of framework in which, let's say you have a pre-trained policy or you fine-tuned it already for your use case. You can kind of deploy it on your physical robot arm and then have it very accurately do this actual fine-grained task that you need to do. So there is, of course, like a lot of more theory and a lot more concepts that go into.
That's amazing, by the way.
Yeah. It's so
I know you said that in about like 10 seconds, but It's like such an amazing, zero shot sim drill transfer for like contact-rich assembly. That's just
It's insane. Yeah.
mind blowing.
And you guys can see like how impressive this is. So these are some very specific tasks that I spoke about. Gear meshing, nut threading, these kind of things. You can imagine these are very difficult to do, right? Like even if you do train a policy for it to perform sim to real, it's just, it's amazing work. Definitely check out this website and the paper as well. There's a lot of good information here. I believe we also have some code coming soon. And so whenever that's out, we could do, if people are interested, we could do like a more focused episode on that as well. So yeah, that was the first one. Now let's take a look at the second one that we spoke about. So this one is called Automate. This one is interesting because it's a whole collection of things. So you have some models that are more specialist. So they're trained for specific tasks. I believe you have 20 or 80 of these more specific, let's see. So the specialist policy can solve 80 assemblies. And assemblies here mean like different tasks that a robotic arm would do for assembly task. And then you have a generalist policy that can solve around 20 assemblies. So in total, like you have 100 tasks that this framework can do, that the system can do. And again, like pretty similar to Forge, you can actually achieve this zero-shot sim-to-real transfer. So that is pretty cool again, because you can do all your training in simulation. You can make all the learning mistakes that you want to make in simulation, and then have a zero-shot transfer to the real arm.
Right.
So yeah.
That's pretty amazing.
It's pretty amazing. Again, I'll be sure to share the link to this. You can check out the data set and all the different parts that are part of this data set. This work also, I believe, includes a bunch of like sim-ready assets. Sim-ready assets meaning you can use these in simulation and set them up for your digital twin. So it's a huge collection of stuff. Definitely check out this website. But the interesting thing is that both of these projects we just spoke about, so Forge and Automate, both of them are now integrated into Isaac Lab 2.2. So that means that if you're using Isaac Lab, you can actually use these frameworks and these libraries for your manipulation tasks. So I think that solves a lot. Like that's pretty interesting because, of course, you can like then fine tune the policies as well for more specific things. Okay, so then we spoke a little bit about that. Let's move on to performance and usability improvements with this release. So there's a couple of concepts over here that I'll kind of go over briefly, but then I'll provide the links so you can actually try it out like with actual tutorials. So this includes support for faster scene creation. And a couple of features that help faster scene creation are called stage in memory and cloning in fabric. Very briefly, what these mean is that stage in memory, as the name suggests, kind of means that your USD scene or the stage that you're working with in simulation, that can actually be hosted in memory in a way that there's minimal like CPU, GPU transfers. And that just makes the whole thing more efficient. So you can basically, once you launch the Isaac Lab or Isaac Sim GUI, you can actually render that scene much faster. So that's just one way. And then cloning.
Are you saying that it's stored in the GPU memory?
I believe so. I have something open here that actually.
That sounds really cool.
Yeah, exactly. Oh yeah, let's see. So I have this link here for stage in memory. It constructs in memory rather than with a USD file. And then if rendering is required, I mean, of course, yeah. So you still need like the GPU to render,
sure.
Whatever. Yeah, but this is, I'll share this link as well. It has more usage examples. I actually haven't had a chance yet to try these out myself, but I know I will be doing it soon. Cloning in Fabric was the second one. So fabric cloning, this basically means there is this fabric library from NVIDIA, more information here, but it's an easier way to load all your data in the scene. And in this way, you can actually clone multiple different environments. So if you're using like in parallel a lot of environments, fabric cloning allows you to load and use all of them much faster. There's also some in this link, I believe. We have, if we go way down, there we go. There are some benchmarking results that we've observed. So if you in parallel want to clone, let's say, 4,000 environments, right, with the shadow hand robot, so this is one type of robot that it supports, then with these two features enabled or not enabled, so stage in memory and fabric cloning, we have these bunch of tests, and you can actually see like storage time or any time going down. So basically, it makes things a bit faster when you're using some of these libraries. So this is, again, pretty cool. I think some environments have...
Not just a little faster. I mean, that was like...
a lot faster.
From 3.8 seconds to 0.1.
Yeah. And look at this. Like if you have fabric cloning not enabled in the final case, it takes this much time. And then with fabric cloning enabled, it takes just 3.8 seconds. So it's a
Wow.
huge jump. Yeah,
Wow.
like a noticeable jump. And what's good is that fabric cloning, I believe it's already enabled by default in some environments, maybe not in all. But then you could enable it in your other environments as well.
Cool.
Yeah. So that's a pretty cool optimization. Some other things. So let's see. We have new OVD recorder for large scene GPU based animation recording. So what this means is that let's say you've created your scene, you have some animations in there. So like you have some things moving around, maybe the camera is moving around, and you want to capture all of that as it is into your next scene, right? What this allows you, the OVD recorder, it actually lets you capture all that animation. I have another link to a more detailed, and again, these links that I'm sharing here, they're already part of the documentation. So you can like dig in and start running them. But yeah, till now we used to have this thing called the stage recorder. So the OVD recorder is now another way to do it. I believe it just makes things faster. So yeah, it motion and USD properties, these are things that can change in your scene, right? Like objects moving, but also their properties changing, like maybe colors changing or the physics might be modified. All of that can be recorded in the OVD recorder such that it's baked directly into an animated USD file, which means that the next time you open this USD file in Isaac Sim or in Isaac Lab, it will already have that animation built in if you've captured it with OVD recorder. So it makes things easier. It basically makes your workflow, it kind of makes it easier to collaborate as well, I imagine, because you can share like this pre-animated USD file with your team working on it. So that's another optimization. And then we have something called FSD, which is Fabric Scene Delegate, for improved rendering speed. This one, again, I don't know much about this because I haven't had a chance to try it yet. But the Fabric Scene Delegate is almost like, imagine like a bridge between your scene data. So everything, all the objects and physics and USD properties that you have in your scene, it's a bridge between that scene data and the rendering engine. So it just makes the rendering process so much faster. And you can actually observe that while using this new release of Isaac Lab.
Well,
So
and it seems like for a few of these, the name of the game is transferring data between CPU and GPU less.
Yes, correct. Because that's where the bottleneck.
That's the bottleneck. And I
Yeah.
think the Fabric Scene Delegate is another way that we've reduced those transfers. Is that right?
Mhm. Exactly. I believe so.
Yeah.
Yeah. I don't know the workings exactly, but I do think it's at the end of the day, it's a game about reducing copies, memory copies, and just making sure you can kind of render scenes directly from the GPU.
Right.
Yeah.
Great
Okay.
stuff.
So yeah, it's really cool. I'll send all of these links in the chat if not already. And then we have finally.
Yeah, if you wouldn't mind putting those in the private chat so I can post them to LinkedIn too. I'll make sure we get those to LinkedIn.
Oh yeah, absolutely, for sure.
So don't worry. So the you LinkedIn folks, you're not seeing all of the chat because we're on this StreamYard platform and we've got YouTube going, we've got X going in, we've got LinkedIn going, and but don't worry. As she posts stuff to YouTube, I'll post stuff to LinkedIn, so nobody misses out.
Everyone gets the links.
So should we take a few questions? That's so cool.
Let's do it. Yeah, I was just gonna say like the last thing I wanted to talk about was improved documentation. This is something for people who've actually tried the previous Isaac Lab repo and like run examples. You will see improved documentation in terms of just updates to the teleop system, what Oyenda was talking about, some VS Code integration. So these are definitely things that if you try it out, you will see all these improvements. And with that, just wanted to share that we'll be talking about Isaac Sim updates very soon in the next live stream next week. And for now, let's move on to some questions.
Yeah, I think before we move on to one question, there's something I wanted to add about the Contactrich manipulation tax. So there is a blog that went out about the sim to real application of one of the papers, which is, so we have different papers that covers Contactrich app manipulation from SRL Lab. We have like industrial, automate, matchmaker, and all of that, and that is in the R2D2 unlocking robotics assembly Contactrich blog. I think Eric already posted that. But then the environment that was used, to be able to develop, the sim to real gap, the sim to real example for for industrial robotics assembly is actually what is being released in 2.2. And that is really interesting in that you could actually try this in simulation, and then you can also do the sim to real part. For the sim to real, the code for that is going to be released soon with the next release. With the next release of in which we'll definitely announce as it comes, and all of that, so that we can also try it. But it's interesting that that environment is available for us to try out, which means that it has been tested for real applications and all. So yeah, thank you. I think we can take some questions right now.
I just want to share this comment first. Best part, better documentation. And absolutely. I mean, the better the docs are, the better we can learn the tool, right?
Yeah.
Let's see. Interesting question. How exactly can we use Isaac Lab to create digital twins? Isaac Lab is actually a robot learning tool. And so and Isaac Lab is, I would say, it's kind of a platform or a tool that orchestrates simulation in Isaac Sim, so that you can train robots. And you would typically make your digital twins using Isaac Sim or another Omniverse app. And if you want to learn more about that, join us next Wednesday. We'll be talking about everything that's new in Isaac Sim 5.0. Let's see here.
Thank you.
Oh, this is an interesting one. Is it possible to collect partial demonstrations and still use them for training?
Okay, so when we say partial demonstration, like what do we mean? Does it mean like half of the task, or does it mean like maybe few demonstration
I
and also we'll have
I'm
to
gonna
clear.
I'm gonna go on a limb and say probably would not work very well. Because just like Asa was talking about, you have to be so meticulous with these demonstrations or they just won't work very well. And so if you only have a partial demonstration, and I think we've all been there, we're doing a demonstration and our USB cord gets unplugged, something like that. It's really sad, and you want to, just like sit down and cry, but
Yeah. I think
unfortunately, yeah,
yeah, that's why teleup is a little bit harder, right? If your demonstration is not precise or to the end of the task, it might not resolve in having a good model, because your model is going to learn bad demonstration. So that's the only part. So if you want full demonstration, if you want your model to learn full demonstration, then you give it full demonstration. But maybe more context on what partial means would be really helpful. You know.
yeah. Let's see. Can Isaac Lab 2.2 integrate multi-agent reinforcement learning with real-time sensor fusion for collaborative robot tasks? And I guess the way I'm interpreting that is, can you have multiple agents that interact with each other, and can you have multiple sensors of different kinds? And uh, direct environments support multi-agents. Managed environments do not support multiple agents yet. The last time I read the docs,
Yeah.
but other than that, yeah, no problem. You
Yeah,
bet.
I think maybe we might need to do an office hours of multi-agent reinforcement learning soon. If that is an interest, we'd like to know from the community. Yeah, definitely we have two multi-agent environment right now, which is two shadow hand passing a pole from one hand to another hand, which is more like a collaborative, more like a task like that. But of course, we also have like sensor in the loop rendering happening right there. So that's the task that can be checked out. And if there are more questions on that, we'll be happy to answer that on multi-agent reinforcement learning.
Yeah, and I would say another somewhat related question I hear a lot is just about using the tiled renderer to be able to train with vision. Do they call it vision in the loop, or
Yep.
integrated vision? So basically, if you want to train with your sensors with reinforcement learning and directly include the sensors in the policy, how do you do that? And I think step one is get a big GPU. 'Cause but
Well,
hey, we sell those, so
well, I mean, I've tried the difference in running just with and without time rendering, and I must say that without time rendering, I couldn't even render up to like 20 cameras on a
oh,
um
really?
4090 GPU.
Oh,
But
you're not
right.
getting anywhere with 20
w-
environments.
Yeah, I'm not going to get anywhere. But with time rendering, you can actually, from documentation, you can actually render up to like a 500 to 1,000 environment in parallel with time
On a
rendering,
on
which
a
is
4090?
interesting. Which is interesting. Um, um, so definitely on the 4090, but of course we also want people to also try the Blackwell GPUs. And it's good for me
Wow,
to
okay.
mention that a lot of people had issues with rendering with Blackwell GPUs. That has been fixed in 5.0 Isaac 5.0, so there won't be any rendering issues when you're using any of the Blackwell GPUs. And also, that's very exciting to know.
And to be honest, I do wonder. Usually I kind of caution people about trying to train policies with the camera included, even without rendering, just because not only is it just the rendering is intensive, but because of the high number of observations, my intuition says that it would take a long time to train those policies. But I have been just very curious. You can include some of that privileged data and do like an actor critic style uh, uh, training. And I do wonder if it would be reasonable to train a policy using the tiled renderer plus actor critic. And I don't know for
Yeah,
sure. But I think that would be a really interesting office hour to. I
yeah,
don't know if you know
definitely,
about that, Oyinda.
definitely. Yeah, time rendering basically is the sensor part, like rendering the camera part. So you can definitely use it to train both imitation learning.
Mhm.
Like I've seen yeah, some of the group fine tune N1 tasks whereby you need the cameras instead of people using the regular camera config, people use a tie camera config, which is faster. And then for reinforcement learning, you can use actor critique, PPO, or any of the algorithms right there, TD3, and all of that. So that actor critique is the algorithm part of it, definitely, but the style rendering is just a sensor part of it. So both of them they can be done in parallel since they don't affect each other, definitely. Yeah.
Okay.
It's
Wow. This is a wild
Asa, do you
one.
want to take this one?
All right.
This is a one that I don't actually. Can you guys help with replaying trajectories while switching between different action spaces, such as velocity control to position control? I'm gonna say I don't know about this one. Like, it's not something I've really tried.
Yeah.
But do we at least know if
Yeah.
like, yeah, do we have some reference for this that we can point to?
Yeah.
I think
I
this
mean,
would be a great one for it to take to the discussions on the GitHub
Hmm.
site.
yeah.
Or you can bring your question to we have the Discord Isaac Lab study group where sometimes we'll talk about stuff like this.
Yeah.
But
Yeah.
yeah.
It's good to also mention that the telehub example, we have different action spaces. We have joint position action space. We have inverse kinematics, which is the end effector pose action space. So definitely both the joint space, the tag space, you can actually use the replay dot py, I mean replay underscore demo dot py, which is on that teleoperation documentation to replay that data set and all. So definitely that can be done. But if you want more specific, okay, example, okay, this is my project, I'm trying to do this, then that'll be a Discord channel or maybe the GitHub channel.
Yeah, and I think we can help. But we of course mean the larger community can help as well. Like if this is something people have tried, then Discord or GitHub issues on the Isaac Lab page, that would be the best way to find people who may have tried this before. I love this comment. It says, "This is so awesome. So excited to dive into Lab 2.2. The better the docs, the better Omniverse Dev Assistant gets to." That's true. Like,
Yeah.
That's true.
yeah.
And I'm telling you, to be honest, I was a little bit slower than I should have been to like the agent game and using agents to help me code. And I've really had more of a focus on doing that within the last few months. And it is such a game changer because I don't have to, I don't know. It's even hard to describe how good it is to be able to go to an agent and just say, "This is the problem I have. Can you help me?" And then have it read through the entire body, multiple bodies of documentation for you, and compile the answer for you. And give you like a code snippet.
You save so much time. That's true.
Oh my
It
gosh,
really integrates. Yeah.
it's game changer.
Totally agree. I can take this one. Which teleoperation device is recommended for Groot Mimic? Is it the Apple Vision Pro? So yes, definitely the AVP is recommended, and we have tutorials showing you how to do that for Groot Mimic. But then in addition to that, like I know the Apple Vision Pro is not that like it's not like everyone necessarily has one, right? But what you could also use instead with Groot Mimic is the Space Mouse. So the Space Mouse is that cool like 3D looking thing that you can actually give like basically it increases your dimensions for controlling like a robotic arm, or any other robot in Isaac Sim. So I would say Apple Vision Pro is an option, Space Mouse is an option. Honestly, we also have some direction on doing it with your keyboard. The keyboard it does, I guess, yeah, it does feel way different than using an actual device.
I was going to say an SO101 leader, though.
Oh yeah, perfect.
Because I feel like if you as long as you have the same degrees of freedom,
yeah,
you could probably map an SO101 leader to just the follower of your choice in Isaac Sim. And
yeah,
I haven't done it myself, but as I've thought about how would I want to teleoperate, and just using the SO101 leader follower config is so intuitive and easy that I feel like that's probably what I would want to use.
That's true, because once you set it up, and it doesn't take that long to set the SO101 either.
Yeah.
So once you've set that up and configured everything, yeah, it's way more intuitive, maybe even more than the Space Mouse, I would say.
I would say, yeah. And I haven't used the Apple Vision Pro, so I don't know how intuitive that is. But from what I've heard, it's quite good.
Yeah,
definitely. Oyenda has a lot of experience using the Apple Vision Pro.
Well, I think the what is not
the gear team, the guys who trained Groot are always trying to grab people like Asa and Regan to be like, hey, do you want to teleoperate a humanoid for a couple hours?
Yeah, I've used the keyboard, the Space Mouse, and the Apple Vision Pro, but the what is not recommended. The what is what you have. You can use what you have. That's what I want to bring it down to. And of course, if you want to spend more, of course, the more you spend, the more easier it is to be able to use many of these platforms. Like I would say, Apple Vision Pro, XR clients are much more easier for you to use, maybe than the Space Mouse or the keyboard, because you're working in a 3D space right now.
Yeah.
So like your hand is moving, you're seeing how your hand is moving, and the manipulator, the humanoid is moving, and all of that. But of course,
you can see what the humanoid sees, right? That's the only one where you can see from the humanoid's point of view.
Exactly. But of course, for humanoid environment specifically, we recommend the XR, because you can use a keyboard to control both the two arms at the same time for by manipulation tasks and all. So that's what I would say. Maybe if there's anything recommended, XR devices are recommended.
Definitely for humanoid. That's a good point. For manipulator, you've got a lot more options.
Yes.
For AMR, even more options. That's easy.
Yeah.
Just drive.
All of the devices do have a bit of a learning curve. Like obviously you need to spend a couple of hours getting comfortable and configuring it basically to how you use it. But I think once that's done, it becomes fairly, like, I think intuitively you build that muscle to learn about, what is a good demonstration? Like, how do I record a very accurate data point that can be used for training? Like, it does take a little bit of trial and error for sure.
That makes complete sense. Yeah.
There's an amazing comment from Lichia saying, happy to collaborate on some of my SO101 workflows on Groot Mimic, Cosmos, and Groot N1.5. That's great, you guys. Yeah, like this is how we want the community to start working together and building stuff together. And that's kind of the point of these office hours and like the discussion on Discord and stuff. Because we know all of you are doing cool things, and it's great to share, right? It's great to see people who are also building using Groot and Cosmos. And of course, like this is the best platform for you guys to ask your questions and share what you're working on as well.
Yeah.
Yeah, go ahead.
Oh, okay. I saw that Brev now has Isaac Sim integrated, as Isaac Lab integrated. That would be awesome. That would be amazing.
I think we're working on it, right?
We do.
Yeah,
doing it.
Process,
yes, it's in Brev. Yes, I know. And we will cover a lot more on Brev next week in Isaac Sim Office Hours, because that's a whole lot of huge help to developers that maybe probably don't have like physical GPUs to be able to try even high-end GPUs to train your models. Up to, I think I said, do we have up to like H1? Like we have those really high-end. Yeah. So definitely
whatever. Very high-end GPUs available.
Exactly.
Yeah. And you guys should try Brev out. Like for anyone who, let's say you want to try a GPU out before actually buying it, right? For your use case, see if it works. Brev is great because you really just log on, you kind of pay for the time you use it. You can pick your configuration of GPU as well. And you can really run some heavy workflows on it. Something that you obviously may not be able to run on like an edge device, like a Jetson or something. You can do actual training with these GPUs that you can reserve on Brev.
Yeah, I mean, you can run Cosmos.
Yeah.
You can, I mean, you can, any workflow, the heaviest, these really heavy duty workflows where you're like, well, I'll never get to actually do that because I don't have 200 gigabytes of VRAM. I don't know how many, but no, Brev. Yeah.
Yeah.
You can try it out.
Okay. Okay, I think we have time for maybe another question or two. The NVIDIA repo, which is Omniverse Blueprints SMMG, Synthetic Manipulation Motion Generation, that requires an A6000 VRAM to collect metadata for Cosmos with Mimic. Yes. Same for the new tutorials. I think short answer is no. Like by no, I mean that based on which tutorial you're actually running, I believe the exact hardware requirements for that will be a part of the tutorial. So I imagine for let's say just the inference side, you will probably need a less heavy GPU, right? Because inference, obviously, it's more like optimized or something. It depends on if you're doing training or fine tuning, then you'd probably need like a bigger GPU. So I think this will be more on a tutorial by tutorial basis. Like you just go to the one that you actually want to run and see what the requirements listed over there are.
Yeah, and I'll say along the same token though, if you're trying to do like a Cosmos Predict tutorial, it's probably will have a higher GPU than
Yeah,
48. I think it's more like 96.
I think so.
For that, you're probably going to want to look at Brev.
Yeah. So one thing is to look at is some of these models, trained models, they are open source on Hugging Face. So we can, and also some of the data set that are being used, like the physical AI data sets, they are open source on Hugging Face. So this can be downloaded if you don't want to go to the process of training and all, because the part that actually need the heavier GPU is the training part. And if we want to post train any of the Cosmos model, yeah, welcome to use like Brev to be able to do that. And then for inferencing, you can use what you have, the GPU you have. Definitely, we definitely recommend, of course, with the new releases of our Blackwell GPUs, we definitely do recommend people to try that out and see how well that works well. Um, but many of these tutorials can be run with a minimum requirement that is listed on Isaac Lab documentation.
Also, if you guys are interested in, so I know earlier in today's live stream, we did talk a little bit about closed loop and open loop evaluation. If you guys are interested, last Wednesday, we had a live stream in which we showed an example of some teams at NVIDIA who are doing closed loop evaluation on an AMR using Cosmos and a bunch of things from Isaac Sim. So feel free to go check out that live stream because I think it'll really give a good use case of how to use Cosmos-like models and Isaac Sim-like platforms to really build and really test on your physical robots as well. So over there, we looked at an example of an AMR, but I'm sure with other live streams, we'll also be talking about more examples, like maybe robotic arms and humanoids, stuff like that.
And I'm going to post a link to the AI Playground where you can try out Cosmos for free, which is really cool. Let me see here. Just posting it on LinkedIn and.
Yeah. Well,
One more question here. How can NVIDIA Robotics contribute to training technicians, developers of industrial robotic applications through using holographic technology? I would say, instead of using holographic tech, I would look at XR tech for this. So, like if having an Apple Vision Pro, with Apple Vision Pro, you can view open USD scenes together. You can, link. You can use Omniverse XR to let people collaborate in augmented reality scenes. Let's see. Oh dear. There we go. And I think that's about what we have time for. We're over time, and I'm sorry.
I think we covered most of the questions actually. So this impressive. This good.
What a crack team, right? We did great.
Yeah. So we look forward to what everybody is able to do with these new tutorials. Like I would say, Isaac Lab documentation has been heavily improved, even from, okay, how to get started. Okay, I'm working with JetBot. Okay, I have a new project. How do I even get started from scratch? I don't know anything about reinforcement learning. How do I get started? We have this documentation. We also do have our robot fundamental courses that are on our DLI platforms, and that is going to really help everyone get started. So we'd love you to try all of these things, and we'd love to get feedback from you on our platforms. Yep.
Absolutely. And we hope, and we're so glad you've joined us. We just love hanging out with all of you. And just a big thank you to Asa and Oyinda for joining today. And I think We hope you'll join us on Discord here in 15 minutes for our office hour, for our study group led by Lychee. And yeah, thanks so much for joining. Asa or Noyinda, did you have any final comments before we end the live stream?
Yeah, I just wanted to say thanks everyone for joining. Hope you were able to learn something today and hope you're as excited about this new release as we are. Feel free to start trying all these new features out. And I think you'll actually be able to see some improvements as well in your rendering times or just documentation usage and stuff like that. Yeah, really excited to hear feedback from you guys about all of these things. And thanks so much.
Yeah. Thank you, everyone.
Okay. We'll see you next week.
Yeah, see you next week.